Hello my dear students, welcome back to our channel. This is your physics instructor Sartaj Alam Taj. So today we are going to solve the multiple choice questions of chapter number 2 kinematics of grade 9th. So here we go. The first question about the change in position of body from initial to final point is called distance, displacement, speed and velocity. As we know that the option A is correct. Why? Because distance is a total length of path covered by an object in a unit time where it changes its position from initial point to the final point. So option A is the correct answer. Okay, so moving towards question number 2, there is about the motion of a screw of rotating fan. Okay, as we know that the fan is of a type of rotatory motion, but here what we ask that the screw of rotating fan is circular motion, vibratory motion, random motion or rotatory motion. The screw of a fan is is in circular motion around the center of the fan, so the screw will be in a circular motion. So here we go, the option A is the correct answer. Okay, question number 3, a cyclist is traveling in a westward direction and produce a deceleration of 8 meters per second square to stop. The direction of its acceleration is towards, okay, here the question is that we have a cyclist here and it's traveling towards the west, okay, in the west direction, but he's producing a deceleration of 8 meters per second square. He's moving towards westward, but there is a deceleration of 8 meters per second square. So if we talk about our the directions, this is the north, this is the south, this is the west, and this is the east. Yeah, okay, if a body is moving in the westward and but what the question has been asked that is decelerating, it means that the body is speeding down, so the direction of its acceleration will be towards eastward. So here we go, is there an answer? Yeah, here is the answer. So option B is the correct answer. Okay, a girl walks 3 kilometers towards west and 4 kilometers towards south. Question number 4, what is the magnitude of her total distance and displacement respectively? Okay, we have given the magnitude of a girl's walk. So what have been asked, she's traveled 3 kilometers towards west. So 3 kilometers towards west, here is the 3 kilometer, okay, and what then ask 4 kilometers towards south. Okay, if she's moving towards west 3 kilometer, and again she's moving 4 kilometers towards south, so this is the 4 kilometer. So what is the question? They're asking what's the magnitude of a total distance and displacement respectively. So here we'll find the total distance and displacement. So we know that the distance is the total length of path covered by that cyclist or that girl. So what will be the distance? So the distance would be 3 kilometer plus 4 kilometer. So here we go, it will be of 7 kilometer. So the distance is 7 kilometer. Okay, while coming towards the displacement, we know that the displacement is always measured between the initial point and the final point. So we will meet the first initial point and the last ending point. So it's the displacement means d. So to calculate d, the displacement, we use the Pythagoras theorem, because it's the I know the right angle triangle. So to find the one side of the right angle triangle, we use what? The Pythagoras theorem. Pythagoras theorem. Okay, Pythagoras theorem. Okay, here we go. Pythagoras theorem. What's Pythagoras theorem? So it's about d square equals to 4 square plus 3 square. Okay, so 4 square 16 plus 9, and what is this? 16 plus 9 equals is of 25, but here is square. So if we remove square here, so the answer will be of 5. So we've got the answer that the displacement is 5 kilometer and the distance is 7 kilometer. So the correct answer, we have got the 7 kilometer and 5 kilometer. Here we go. It is the, here any answer 7 7 1 7 7 1 and 7. Yeah, here we go. So option D is the correct answer. Okay. A rider is training a horse. Horse moves 60 meters towards right. Question number 5. Right in 3 seconds. Then it turns back and trails 30 meters in 2 seconds. Find its average velocity. Okay, a rider is riding a horse. Okay, is training. What we have asked to calculate the average velocity. Okay, to calculate the average velocity, we know that the average velocity, the total displacement divided by total time. Okay, so what is total displacement is about 60 meters plus 30 meters is the total displacement, or the total yeah, total displacement or total distance the horse has been has covered. So 60 plus 30 meter. Okay, and then divided by what's that of time, 3 seconds plus 2 seconds. Okay, what's that? Here we go. Okay, 3 seconds plus 2 seconds. Okay, and I will close it. So 60 plus 30, 90 divided by 5. So if you divide 90 divided by 5, 5 1 times 5, 5 1 5. So 4 5 how many times 5, how many times 40? Okay, 5 8 times 40. Okay, it means we what we got is the 18 meters per second is the average speed. Is here 18? Is here 18? Is here 18? Yeah, okay, here you go. Is the correct answer 18 meters per second. Okay, yeah. Question number 6. If a cyclist has acceleration of 2 meters per second for 5 seconds, the change in velocity of the cyclist is, okay, here we have to find the change in the velocity. Okay, but we have given the acceleration and time. So we know that acceleration is the change in velocity divided by time. So the acceleration is given to us, that is 2 meters per second square equals to change in velocity divided by time. Okay, what's the time? Yeah, 5 seconds. Okay, so here we go. There is of 5 seconds. So you'll multiply 5 with 2 to to find delta v. Means 5 multiplied by 2 times 10. If it's v, then meters per second is the answer, is change in the velocity. Okay, so 10 is the correct answer. So is here this is the correct answer, 10. Okay, so question number 7. A car is moving with velocity of 10 meters per second. If it has acceleration of 2 meter per second square for 10 seconds, what is the final velocity of the car? Okay, we have given the initial velocity, the acceleration, and the time, but we have to calculate the final velocity. Okay, here we go. We know that acceleration equals to vf minus vi divided by t. So what we have to calculate? The final velocity. Okay, a multiplied by t equals to vf minus vi. Okay, yeah. Okay, so the acceleration is, what is the acceleration? Yeah, 2 multiplied by 10. Okay, here 2 multiplied by 10 equals to vf minus, what's the initial velocity? The initial velocity is 10 meters per second. Yeah, 10. Okay, thank you. Okay, 2 multiplied by 10 is the 20. Acceleration is the 20 meters per second square, and the t is seconds, 20 meters per second. Is the minus, then plus equals to vf plus, oh yeah, plus 10. So 10 plus 20 is the 30 meters per second is the final velocity of the yeah, the car. So what's the answer? Is the correct answer is the 30. Okay, when the slope of body's displacement time graph increases, the body is moving with, is saying that if the displacement time graph increase means that the slope is increasing like that, like this. So the body is moving with increasing velocity, decreasing velocity, constant velocity, all of this. No, because decreasing velocity means that the displacement time graph is decreasing. Okay, yeah, and the constant velocity means that we have given a straight line, not all of this, but we have given we have the option A. Okay, increasing velocity. So a ball is question number 9. A ball is thrown straight up. What is the magnitude of acceleration at the top of its path? Okay, at the top of its path. Okay, as you know that it's asking about the acceleration, and we know that at top the velocity is 0. If velocity is 0, it means that we have 0 acceleration. Okay, slope of distance time graph. What we take from distance time graph is the speed. Okay, yeah. Okay, area under speed time graph is equal to dash of moving body distance. Okay, you should have to consult with the given topics which I've given here. If I'm not wrong, yeah, here's the answer. Like that, the area under speed time graphs represent the distance traveled. Okay, here's the proof of given answer question. Okay, so moving towards next question. In 5 seconds, a car accelerates so that its velocity increases by 20 meters per second. The acceleration is, so we have to calculate the acceleration. Means that we have given the velocities. What is the velocity? So we know that acceleration equals is the vf minus vi upon t. Okay, so acceleration equals to okay, what he's asking about that in 5 seconds a car accelerates so that its velocity increases by 20 meters per second. So the change in the velocity, okay, the change in the velocity is the initial velocity is the 0 and the final velocity is of 20 meters per second square. 20 meters per second square. In other words, the change in time is of 5 seconds. Okay, so the acceleration is, oh sorry, not square, the velocity, yeah. So 5 1 times 5, 5 4 times 20. So what we have got, 4 meters per second square. So is there in 4 meters? Yeah, here's the option B is the correct answer. Oh sorry, yeah. Okay, so here we go. Question number 13. Ball dropped freely from a tower reached ground in 4 seconds. The speed of impact of ball is, okay, here we have to calculate the speed, but just we have given the time. So from which equation? Okay, yeah. So here we go. As you know that for vertical motions we use g instead of a, So it's the Vf minus Vi divided by T. So what we have to do to calculate the speed means that we have to calculate the delta V upon T. Okay, we know that the value of G is of 9.8 meters per second square is the delta V divided by what's the T, 4 seconds. So if we multiply 9.8 with the 4, we get V is the 39.2 meters per second. So here we go. Where is the answer? Okay, yeah, here's the answer, 39.2 meters per second. Okay, the last question, question 14. Which of the following distance time graph represent increasing speed of a car? Okay, here we have given the 4 graphs. So the first graph shows that distance is not changing but the time is changing. It means that either the body is moving with constant, as the distance time graph is moving with constant speed. Okay, so here the body is moving with the uniform speed, so it's a uniform graph. Okay, here's mean that the first it was moving slowly, and then it's taking a small time to cover a greater distance, so here the first the car was speeding, and gradually it is taking a greater time but is covering a small distance. So here the speed has almost constant, not this has been increased. Okay, so option C is the correct answer. Why? Because here it's taking lesser time to cover a large distance. Okay, so option C is the correct answer. So thank you so much guys for your kind attention. So after doing these questions, so after this these questions, we will do the short response questions along with the long response questions plus the numerical problems. Here we go. Yeah, here we got some. We have got some numerical problems here, numerical response questions. So thank you so much guys. So stay in touch with our channel. If you haven't yet subscribed to our channel, so please do subscribe our channel for more interesting videos and for interesting lectures. Like we have having lectures of for physics 9, for physics 12, of physics 10, and of physics first year. All of the National Book Foundation is a federal textbook for Islamabad or anything else. So thank you so much for your time. Allah Hafiz.